So section 3.5 is solving nonlinear systems. So just like in section 1.4 when we were solving systems, same idea here, like use substitution, use elimination, those same strategies. The only thing that's different is a nonlinear system means that at least one of the equations will be what it sounds like nonlinear, so it'll be a quadratic. So like in section 1.4, even though there's three variables, it was still a linear system, meaning it was kind of like it was a straight line basically. But now we'll have quadratics where it has the parabola in it. So it can either be a quadratic and a linear equation, or it could be two quadratics. So the first type is to solve by graphing, and that's kind of like you probably remember from Algebra 1 when you first learned to solve by graphing, and it was like you were just looking for the intersection point. So whatever the intersection point was your solution. You can do the same thing here. It'll just be like a parabola and a straight line, or two parabolas where they intersect. But obviously graphing parabolas and quadratics takes way more time than graphing straight lines. So anytime you're solving by graphing, you can use Desmos, and I'll show you how to do it in class just in case. So we're going to skip down to example 2. So solve by substitution. Substitution means that you're solving for one variable and substituting it into the other equation. So in order to solve, I would recommend substituting into the equation that has the quadratic. So like for example 2a, we have x squared plus 2x minus y equals 5. And then we have 2x plus y equals 7. So the second equation is relatively easy to solve for y. We would just have to subtract the 2x over. And then my new equation becomes y equals negative 2x plus 7, or 7 minus 2x. And then now that it's solved for that variable, I can take that negative 2x plus 7 and I can substitute it into the other equation where y is. And then y's will be gone and I'll be able to solve for x. So the first equation becomes x squared plus 2x and then minus y. So it's going to be minus, and we want to put all of y in parentheses. So minus parentheses negative 2x plus 7 equals 5. And then we'll have to distribute the negative. So x squared plus 2x, negative times negative 2x would be plus 2x again, and then negative times 7 be minus 7 equals 5. We can combine the 2x and the 2x into 4x. So x squared plus 4x now minus 7 equals 5. We can subtract the 5 over, get negative 5, or sorry, not negative 5. X squared plus 4x, and then negative 7 minus 5, so negative 12 equals 0. And then now it's in standard form, so we can check to see if it's factorable. So we have to see our a is 1, so we have to see other factors of negative 12 that add up to positive 4. They would be 6 and negative 2. So this factors into x plus 6 times x minus 2 equals 0. And then we can set each factor equal to 0, so x plus 6 equals 0, x minus 2 equals 0, and then so we get two values for x. So we end up with x equals 6 and x equals negative 2. So the solution to a system should be written, and these are just systems of two variables, so it should still be written as a coordinate pair or an ordered pair. And now we have two x's, so we have to figure out the two ordered pairs where the intersection points are. So it's as straightforward as it seems. It just kind of like adds an extra step in. So we would have to figure out what y coordinate goes along with the x solution and x equals 6, and then which one goes along with the x equals 2. This should be I think my signs are backwards. This should be a negative 6 and a positive 2. I'm going to rewrite this. X equals negative 6 and x equals positive 2. So in order to solve, probably don't want to pick the equation that has like the x squared in it. I would pick the equation that's more simple, like the 2x plus 7, or sorry, 2x plus y equals 7. And better yet, you can use the one that you solved for y. So like y is already isolated, you'll be able to get y right away. So the y equals negative 2x plus 7. We'll do y equals negative 2 times x, so times negative 6 plus 7 for when x equals negative 6. And then y equals negative 2 times negative 6, so positive 12 plus 7. And then y equals 19. So when x equals 6, or negative 6, y equals 19. So one solution is negative 6, 19. And then to find the other solution, we'll take x equals 2 and substitute it into this equation also. So y equals negative 2 times 2 plus 7. Negative 2 times 2 is negative 4 plus 7. And then negative 4 plus 7 is 3, so y equals 3. So our other solution is 2, 3. So you have to find the whole point for each possible x value, basically. Whatever x values you find, sometimes it could be 1, sometimes it could be 2, just depending on how the equation is set up. I guess sometimes it could be none also. So for b, it's x squared plus y squared equals 20, and then y equals x plus 2. So same thing, we're solving by substitution. This one is already like solved for y. So the second equation is already solved for y. It's saying that y is equal to x plus 2. So we're going to substitute that x plus 2 into that y squared of the first equation. And then when I do that, I have x squared plus, instead of y squared, it'll be in parentheses x plus 2 squared equals 20. And then x plus 2 squared means all of x plus 2 is being squared, like multiplied by itself. So that would become x plus 2 times x plus 2 equals 20. It's never going to be just x squared plus 4, so that'll always mess you up. You have to write it out and FOIL it unless you know that like part in your head, that's fine. So x squared plus x times x is x squared, x times 2 and 2 times x, those combine to 4x. It's like 2x plus 2x. And then 2 times 2 would be plus 4 equals 20. I can combine the x squared into 2x squared plus 4x plus 4 equals 20. Subtract the 20 over. I end up with 2x squared plus 4x minus 16 equals 0. So I want to get it in standard form. And then from there, I can divide a 2 out of the entire equation because everything's divisible by 2. And I'll just make it a little bit easier to figure out if we can factor it. So when I do that, when I divide out the 2, 2x squared divided by 2, you're left with x squared. 4x divided by 2 is 2x. And negative 16 divided by 2 is negative 8 equals 0. And then now I can check to see if it's factorable. So a is 1, so are there factors of negative 8 that add up to 2? It could be 4 and negative 2. So 4 times negative 2 is negative 8. 4 plus negative 2 is positive 2, so this factors into x plus 4 times x minus 2 equals 0. Set each factor equal to 0, so x plus 4 equals 0, x minus 2 equals 0. Subtract 4 from both sides, get x equals negative 4. Add 2 to both sides, get x equals 2. And then you have to find the y's that go along with each x. So we already have an equation that's solved for y, so that equation is going to be your best option to substitute in these x's and solve for y. So it's y equals x plus 2, so y equals negative 4 plus 2. So y equals negative 4 plus 2 is negative 2. So when x equals negative 4, y equals negative 2, so negative 4, negative 2 is one solution. And when x equals 2, same thing, substitute into this equation. So y equals x plus 2 will become y equals 2 plus 2. and then y equals 4. So for the point when x equals 2, y is 4. So 2, 4 is our other solution. And then for example 3, it's solved by elimination. So when we solve by elimination, that's when we like add equations together in order to eliminate some variables. So we have 3x squared plus 2x minus 2y equals 10, and x squared minus 6x plus 2y, plus 2y equals negative 12. So in order to solve by elimination, the biggest thing is you have to make sure that all of the variables are lined up correctly. So like x squared with x squared, x with x, y with y. And then you're welcome to add or subtract whatever you need to do in order to eliminate the equation. So it's your best option is to eliminate y. So when you're solving by elimination, you want to eliminate y. Because think about what we did in substitution. Like we substituted in for y so that the x's disappeared. So that the y's disappeared and we only had x's, and then we could solve it as a quadratic basically. So same thing here, you want to eliminate y first. So this is already kind of set up to eliminate y because I have negative 2y plus 2y. So I can go ahead, I can add these two equations together. So 3x squared and x squared, if I add those I get 4x squared. 2x and negative 6x, so I add those, I get negative 4x. And then negative 2y plus positive 2y, those cancel out, which is what we were trying to do. And then 10 plus negative 12 is negative 2. And then from there, I can get this equation in standard form, so I can add the 2 over. Or, yeah, we can add the 2 over. Then I have 4x squared minus 4x plus 2 equals 0. I have a common factor. I can divide out a 2 here just to give me smaller coefficients. So 4x squared divided by 2 is 2x squared minus 2x plus 1 equals 0. And then first you should check to see if it's factorable. So it's a times c, so a times c is 2 times 1, which is 2, and then are there factors of 2 that add up to negative 2. So the factors of 2 are just 1 and 2, and there's no way to like get those to equal negative 2. So it's not factorable. So then you can either complete the square or you can use quadratic formula. So it's entirely up to you. I'm going to complete the square. So I'm actually going to subtract the 1 back over. So we'll subtract the 1 back over. So it's 2x squared and then minus 2x equals negative 1. And then I'm going to divide by a. So remember, like we want a to be 1 when we're completing the square. And there's a different way of doing this, and I'll show you guys in class. But the main way and the way the textbook shows is just by dividing by a. So 2x squared divided by 2 is x squared. And then negative 2x divided by 2 is negative x, and then negative 1/2 divided by 2 is negative 1/2. So b over 2 squared is what we have to add to both sides. So b over 2 squared is going to be negative 1 over 2 squared. Negative 1 over 2 squared is 1/4, positive 1/4. So I have to add 1/4 to both sides. So x squared minus x and then plus 1/4. And then negative 1/2. I'm actually going to change the negative 1/2 into negative 2/4 so that I have common denominators. Plus 1/4. And then I know that this can factor easily because I just completed the square. In order to factor easily, factors into x. And because this is a minus, it'll be x minus b over 2. B over 2 was negative 1/2, so minus comes from there also. So minus 1/2 squared. And then equals negative 2 over 4 plus 1 over 4. You just add the denominators, so this is negative 1/4. And then you can square root both sides. So when I square root both sides, x minus 1/2 is what I have on the left. And then the square root of 1/4, the square root of, or negative 1/4, the square root of negative 1 would be positive or negative I over the square root of 4, which is 2. And then I can add that half over. So x equals, if I add the half over, these are common denominators, so I can kind of combine it into like one equation. So 1 plus or minus I over 2. So then you're probably wondering like, okay, well, how do I plug an imaginary number in and then solve that equation for y? Well, you don't. So as soon as you find that x is an imaginary number, you can say no real solution, because that's true. It's not a real solution. It's going to be imaginary. It is imaginary. So you can stop there and say no real solution. And this type of problem, like, you're perfectly welcome to use quadratic formula and stuff like that. That's more of just like subbing things in and simplifying. So I try not to show that as much as I show completing the square. And then for example 4, it says solve using any method, explain your method. So like substitution or elimination, I'm going to do these on a separate sheet of paper. So this would be like a good time to pause and to try these ones on your own, and then just to play when you're ready to check your work. So for number 1, I would really recommend using substitution, because they're both already solved for y. So like, if like say I'm looking at this equation, the second equation is claiming that y equals negative 4x plus 8, that can get subbed in here for y, or you can think I'll just set y equal to y in general, and so you're just setting what you're like claiming y to be equal to. So like obviously y equals y, so I can set x negative x squared plus 4 equal to negative 4x plus 8. So you can also use substitution. You just have, or I mean elimination. You just have to make sure like you keep your signs right and everything like that, and you don't mix like non-like terms. But if you use substitution, it looks like this. And then we want to, this is a quadratic, we want to get it in standard form, so I'm going to move everything onto one side of the equal sign. So I'll add 4x to both sides. Get negative x squared plus 4x plus 4 equals 0, or sorry, equals 8. And then subtract the 8 over now. Get negative x squared plus 4x, and then 4 minus 8, so minus 4 equals 0. And then you want to avoid factoring like when a is negative, so anytime a is negative, just divide out a -1 basically, unless there's like a number that you can divide out. So I just have to flip all the signs. So negative x squared becomes positive x squared, 4x becomes negative 4x, and negative 4 becomes positive 4. And then now I can check to see if it's factorable. So like a is 1, so I'm looking for factors of 4 that add up to negative 4. So those factors would be -2 and -2. So those factors into x minus 2 times x minus 2, or you do x minus 2 squared, it's up to you. And then you could set each factor equal to 0. And obviously you don't need to write it twice, they're the same factors. So x minus 2 equals 0, add 2 to both sides, and get x equals 2. So because you just have that one solution for x, you only have to worry about finding the one solution for y. So you just need to take that x equals 2 and substitute it into one of the two equations. Probably the second one is easier. So y equals negative 4x plus 8, so negative 4 times 2 plus 8. And then y equals negative 4 times 2 is negative 8 plus 8. Negative 8 plus 8 is 0, so y equals 0. And then we just need to write our final solution as a point, so our final solution is 2, 0. And then for the next problem, so the next problem is 2x squared plus 4x minus y equals negative 2, and x squared plus y equals 2. So you can use substitution or elimination. It really doesn't matter. Number 3 is set up for substitution, so I think I want to show you elimination here. The biggest thing though, like I need to stress, is your goal, like you want to eliminate the y's, whether you're using substitution or elimination, just because you want to. It's okay if you end up with like multiple powers of x, but like say I were to try to eliminate x squared here, I would still have an x and a y, so it doesn't really do me any good to try to eliminate one of the x's, but it does help a lot to eliminate y, because then I can solve x squared and x like a quadratic. So if you want to use elimination, you just have to make sure that you line up your variables. So like this one is set up pretty well to use elimination because we have negative y, like negative 1y and positive 1y, so those will cancel out right away. We just have to line it up correctly. So like 2x, I'm just going to rewrite this equation the same because it's not missing any of the terms like this one is. So 2x squared plus 4x minus y equals negative 2. And then for x squared plus y equals 2, I have to like make sure I leave kind of a space or a placeholder for the 4x. So x squared, and then I'm just going to leave a gap. I'll line up my positive y under my negative y, and then equals 2. So because it's a negative 1y and a positive 1y, I can just add the two equations together. So 2x squared plus x squared is 3x squared. I just basically have to bring down this 4x. There's nothing I can add it to, so plus 4x. Negative y plus y, those cancel out. And then negative 2 plus positive 2 is just 0. And then now I can check to see if it's factorable, and I know like sometimes when there's just an x squared or like an ax squared and a bx term, people will like get a little stumped, but just always remember to look for the GCF first, so the greatest common factor first. So in this problem, or between 3x squared and 4x, the GCF is x. They both have an x, so I can factor that out. And then like 3x squared divided by x leaves you with 3x. 4x divided by x leaves you with 4 equals 0. And then now this is factored fully, and I can set each factor equal to 0. So x equals 0, and 3x plus 4 equals 0. Subtract the 4 over, get 3x equals negative 4. Divide both sides by 3, get x equals negative 4 thirds. So you end up with x equals 0 and x equals negative 4 thirds. Those are our two x values. So we have to find the y's that go with both of them. So for when x equals 0, it doesn't really matter which equation you pick, but probably the second one is going to be easier, less terms. So we'll substitute in x 0 for x, so it'd become 0 squared plus y equals 2. Obviously 0 squared is still 0, so you get y equals 2. So our first solution is 0, 2. And then for x equals negative 4 thirds, you're substituting in negative 4 thirds for x. So if we use the second equation, this would become negative 4 thirds squared plus y equals 2. If you're squaring a fraction, you just square the numerator and the denominator. So negative 4 thirds is positive 16 ninths. Plus y equals 2. I know I'm going to have to subtract this 16 ninths over, so I kind of want to get common denominators now. So I'm going to change 2 into 18 over 9 because I want the denominator to be 9. So I'm basically like multiplying 2 by 9 over 9. So that's where the 18 over 9 comes from. And then now I can subtract the 16/9 from both sides. And then I'm left with y equals 18/9 minus 16/9. If you're adding or subtracting fractions, you just add or subtract the numerator. So 18 minus 16 is 2/9. So we have y equals 2/9. That was when x equals -4/3. So that solution is -4/3 and 2/9. And then for number 3, it was x squared plus y squared equals 16, and then y equals -x plus 4. So like I said, this one is set up really well for you to use substitution because it's already solved for y. It would be like kind of actually impossible for you to solve using elimination just because like there's no like terms between all the equations because this one only has x and y squared and this one only has x and y. So we're going to take what we're saying y is equal to the -x plus 4 and we're going to substitute it in for y squared. So this first equation becomes x squared and then plus y squared becomes plus x minus 4 or -x plus 4 in parentheses squared equals 16, and then x squared, and I have to FOIL this, so this is -x plus 4 times -x plus 4 equals 16. I'll just bring down this x squared and start FOILing. So -x times -x is +x squared. -x times 4 is -4x. 4 times -x is -4x also. 4 times 4 is 16, and then equals 16. And then I can combine like terms so that x squared and the x squared I can combine to 2x squared. -4x and -4x I can combine into -8x, and then plus 16 equals 16. I can get this in standard form, so I can subtract the 16 over. Minus 16, ignore that. And then I have 2x squared minus 8x, and then 16 minus 16 also cancels out, so equals 0. And then if you want to divide out a 2 here, you can. It doesn't really make a difference, but make sure, like, again, especially when you have just x squared and x, like, you have to check for a GCF first because that's the only way to factor this problem. So between 2x squared and -8x, the GCF would be 2x. So 2x squared divided by 2x is just x, and then -8x divided by 2x would be -4. And now this can't be factored any further, so now you can set each factor equal to 0. So 2x equals 0, x minus 4 equals 0. Divide both sides by 2 to still get x equals 0. And then for x minus 4 equals 0, add 4 to both sides and get x equals 4. So you end up with x equals 0 and x equals 4. And then you can take each of those x values and substitute them into the second equation in order to solve for y. So when x equals 0, if you substitute that in here, the equation is y equals -x, so -0 plus 4. -0 is still just 0, so you end up with y equals 4. And then that solution is 0, 4. And then for when x equals 4, if you substitute it into that equation, y equals -x, so -4 plus 4. -4 plus 4 is 0, so y equals 0, so the other solution is 4, 0.